Hello, another interval problem, 119, non-overlapping intervals. This is very similar to the previous problems that we have done. In this particular problem, we're just going to identify the number of intervals that can be removed. And essentially, we need to remove 1 and 3 from this particular interval. So basically, we're removing the one with the largest range and things that overlap between 2 and 1. So basically, these are overlapping and this is not overlapping. Okay, so first thing we do, we need to set our intervals dot sort so that we get the correct item. And like the previous problem, we're gonna use O of n space and O of n time. Of course, there's an easier way to do this, to use O of 1 space, but we'll do that afterwards. So what we're gonna do is set an item, get the first item, and throw it into our interval result intervals, and set the count to 0. Well, actually, we don't need to set the count to 0 because we can count the results later. Let's check this out. So for I in range 1 through length of intervals. So I guess with this we can get the item. So we get the first, the last item in our interval system, and if it is greater than the start of this next item, that means that there's an overlapping interval and we need to reset our minimum. We take the minimum of the two and we throw away the maximum. So result -1, 1, and count plus equals 1. Otherwise, we're going to just append to our results. And then what happens is that we can return the count or result.count. One or the other would work. So run the code. Oh. Let's try it again. Weird. Okay, how about good. I think that's it. So let's see. Is there a better way to do this? Yes. We take the count instead. So the count would result in less, I guess, counting. Run the code. And that would make this a little faster. Another thing that we could do is actually not use this and use a O of 1 space. So we just need a previous end, and that's going to be equal to interval 0, the first item, and the end of that first item. And instead of this, we're going to do for start and end of the in intervals, starting from the first item to the end. And what we're gonna do is gonna get the start to see if the previous end is greater than the start. If it is greater than the starts, that means we have the same problem, and we're gonna set the previous end to be equal to the minimum of the end or the previous end. And that means that we have eliminated 1, so we count plus equals 1. Else, previous end is equal to, this current end. And there is no overlapping. And that's it. And then we return the count. Oops, what happened? Intervals. So basically the same code, but without the space complexity. Well, it's a little slower though. I think it's just the items that we put in to do the test. If we do it one more time, I think it's going to be a little bit faster. So anything else? I think that's it for this particular problem. What did we learn? So we learned that there are multiple ways of getting an interval problem and looking for the commonalities of overlaps and looking for items that we can remove and which ones to remove. And that's what we did here. I think it's just good practice. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. If you want, and have a good one. I'll see you next time.